Okay, so welcome back. This is part 5 in our series where we're showing you how to develop an application that will monitor hardware values on your computer like voltages and temperatures, and you can see here fan speeds. We talked in previous videos about these two applications here. On the left, this is an application we developed in C# Visual Studio Windows Forms that is grabbing two values from the CPU and giving a scrolling real-time plot of those values. In blue on the top is the core temperature of the CPU, and you can see it's plotting it in real time. And in orange on the bottom is the average load on the CPU, and it's plotting that in real time. And what we did is we developed this application from scratch. However, we used a library from GitHub that is represented by this application here. And this is, like I say, a free and open source GitHub library called Libre Hardware Monitor. And it is very much like other applications that are free, but maybe not open source, that you can gather, like Hardware Monitor and other computer hardware monitoring applications. The difference here is this open source. You can look at the code as we did before, and you can use the library in your own code as we did here to grab whatever data you want and do what you want with it. So we talked in previous videos, we went through this Libre Hardware Monitor, how to download it, how to run this application, but also how to install it as a NuGet package if you're going to write an application like we have here on the left and grab data from your hardware. Now, again, this is a free and open source GitHub repository, Libre Hardware Monitor. And it's nice because, as we showed in previous videos, you can use it kind of as a learning tool to see, you go through the code and see if you can figure out what they did, why they did it. And that kind of helps you to understand how you would do it if you did it by yourself. However, one of the reasons that I tend to avoid open source software for actually using it is that in this case, as in many other cases of free and open source software, it's really kind of a challenge to figure out what's going on. And the primary reason is because basically coders hate writing documentation. That's the thing about software coders. They hate it. They like writing code and playing with code, but when it comes to documentation, for some reason, they despise it. So you can pretty much count on open source software having little or no documentation. So if you want to figure it out, you're going to have to spend a lot of time figuring it out on your own. Also, we found that there are some problems with this code, and I won't get into that, but there's some plotting problems. It has a plotting application, and some of the values are wrong, and there's a lot of downsides with open source software. Nobody has to take responsibility for making sure it's right or well documented or the data is accurate or reliable. So, you get what you pay for. So you have to be very, very careful if you need to use this, other than if you're like a hobbyist who just wants to play with their GPU and video games. That's fine. The numbers don't really matter anyway. But in the real world, in the engineering world, if you want to have good data and you want to understand how to develop yourself, it's really not of a lot of use. So what we're going to do in this video is we're going to step back and we're going to try to design an application that does what you see here, but we're going to try and do it without utilizing the library of this Libre Hardware Monitor or any other performance monitoring hardware. We're going to try and figure out how to do it ourselves and just grab one value and plot it as you see here. And once you go through that process of figuring out how to write the code to talk to the GPU or the CPU or the fans and figure out what the values are and plot them, then understanding something like this becomes a lot easier because you've gone through the difficult process of doing it on at least one value, and you can understand some of the challenges. So let's start to brainstorm how we would develop an application and the things we would need to consider. So our goal is going to be to detect and monitor one component and grab one performance value from that component and chart it. We're going to try and do it very easy and simple so we can understand at least the process. So now the first thing we're going to have to figure out is what are the components we're going to have to deal with and how can we communicate with them and grab data. So the first thing I want to do is define what I call the component types. What are the types of components that we're going to have to deal with? The first type is what I call the performer. the hardware that's actually doing the performance. Like the fan, we want to measure fan speed, but the fan is actually doing the fanning. CPU, we're going to measure the temperature and the utilization, but the CPU is actually the hardware that's doing the work. Same with the GPU, it's doing the work. We're going to measure some of its performance values, but these are the hardware, what I call the performers. And you can imagine there's going to be a lot of different types of fans and CPUs and different manufacturers and different GPUs and RAM and storage. And there's going to be many different variations on these. So you can start to see where this might get kind of complicated with all the different types. But we're going to try it on one component, one performer, and see how the process goes. Now, the second component type is what I call the data acquisition device. In the real world, those are used everywhere. In engineering and manufacturing, data acquisition devices are basically hardware and associated software that grab data from real-world equipment. And this is no difference. You can also call it a sensor or a monitor, but basically it's a data acquisition device. So for each of these components, if it has performance data, it has to have a data acquisition device associated with it. So for example, there's a fan. Some device is going to have to figure out what the fan speed is and make it available to you. Same thing with the CPU load and temperature, and same with the GPU and the RAM. So somewhere there's a data acquisition device for each of these, or maybe more than one. And we're also going to have to consider, well, where is that device? Is it on board? For example, with a GPU, is the data acquisition device on the GPU? If you ever looked at a GPU, you know it's got a lot of stuff on it. Maybe it's got built-in data acquisition devices, like with an NVIDIA GPU. Maybe there is a chip on there that monitors GPU performance and temperatures and fan speeds. With a fan, is there an external data acquisition device, or is there a chip in the fan that can measure the fan speed? So when we look at our data acquisition devices, one of the things we're going to have to figure out is where is the data acquisition device for each component? Is it onboard or external? And that's going to matter to us because we're going to have to figure out how to communicate with that data acquisition device and grab data. Now the next thing is the performance data registers. So presumably your data acquisition device is going to grab data, performance data from the component, and it's going to make that data available to you somehow. And you probably can assume that it's going to use what are called registers in memory somewhere with that performance data. And if you know anything about memory, you know it's got basically an address and a value to store a bit of data. So to get the data, we're going to have to probably figure out where is the register, what is the address, and what type of value is it holding so that we know what to do with it. So we're going to get the data from the data acquisition device. It's going to be put into a register somewhere, and we're going to have to grab it and process that data based on what's the value and what's the type of that value. Now keep in mind that this data register could be or is likely a child of the data acquisition device. So for example, if the data acquisition device is a chip, it could have on board with that data acquisition device a data register or a group of data registers holding that data. Or it could be separate, but it's a very important aspect, a very important component that we're going to have to pay attention to because we're going to have to figure out how to communicate with it, with the address and the value. Now, keep in mind that there's also communications with the different devices. For example, your GPU. If you've ever worked with a GPU, you know you plug it into the PCIe slot on your motherboard, and your CPU, which is running whatever performance monitoring hardware info application, is going to somehow have to communicate with that GPU, and the way it would do that is probably over that PCIe bus. So depending on the component, there may be different communication paths that you're going to have to be familiar with and utilize in order to grab the data. So if you're going to get GPU data, maybe you have to do it over the PCIe bus. If you're going to get CPU data, your CPU is already running this application, so maybe you just have to get a register locally on the CPU The fan, depending on where the fan data acquisition device is, you might have to communicate with that. So you can start to see there's a lot of different possible communications infrastructure we might have to deal with, different registers, different data acquisition devices, and lots of different, what I call, performers. And the last thing you have to consider is data access software. So for example, we'll go back to our GPU. Say it's an NVIDIA GPU. It's got a lot of stuff on it. It's kind of like a standalone computer. It's got a GPU processor and it's got registers on it. Maybe with an NVIDIA GPU, for example, NVIDIA provides some software like a DLL or some type of software that makes it a lot easier to communicate over PCIe to the GPU and grab data from the registers that tell you about the performance of the GPU. So maybe for a GPU, you've got certain manufacturer data access software you can use. And maybe for a fan, you have to do it yourself, and so on. So there's either something you have to write yourself, or maybe some library or something, or an application from a manufacturer you're going to have to use to grab that data from the data register and the data acquisition device over the certain communication path. So these are the five, what I call the five major components we're going to have to understand and deal with: the performer, the data acquisition device, the data registers that hold the data, the communications infrastructure, and the data access software. And again, you can imagine there's lots and lots and lots of variations on these, since there's so many different manufacturers and models of all these different performers. There could be many, many, many different variations. So here we've got kind of a graphical depiction. We've got our software. It's going to have to communicate over some communications link to the different types of hardware, like a GPU, CPU, motherboard. And there's going to be, for example, a fan speed put into a register that we're going to grab over this communications. And then we're going to grab this voltage in another register, and so on. So these are the kinds of things we're going to have to figure out how we can implement those in our application. Now, there's one other very important aspect to this that we need to consider. This is a CPU ID HW monitor, one of the many different computer hardware monitoring applications out there. And as you notice, when you start it up, it automatically goes out and detects what motherboard, what fans, what CPU, and so on, even my SSDs. It detects all of that and immediately figures out what the voltages are, what the name of the voltages are. And here's the motherboard. It lists all the voltages that are being read on the motherboard, all the temperatures, all the fans. So somehow the application goes out there and detects and senses all of these different components and the values and the names. So the question becomes, how do we, in our performance monitoring application, determine or sense and detect all of those component types and properties? Keep in mind, laptops and desktops are different, and this gives you an idea of how sometimes maybe you can assume what the components are, and sometimes you have to actually check. For example, laptops generally have fixed CPUs that are soldered in. Generally, a laptop, you're not going to change the CPU, while with the desktops, the CPUs can be changed fairly easily. You can just lift the latch, take it out, and put in a new one. Therefore, on laptops, the CPUs can probably be assumed based on whatever the model of the laptop is, but on desktops, they can be changed. So somehow you're going to have to sense what the actual CPU is and figure out what all the properties are. Same thing with GPU. You can plug in a GPU tomorrow, and it's going to have to suddenly figure out what that GPU, it's going to have to sense it and see what the name is, what the model is, and what all the properties are. So when we do our application, we're going to have to figure out how we can sense those components that we need to sense and which components we can assume. And probably there aren't very many that we can assume. We're going to have to probably sense most of these components. So we're going to have to figure out how we're going to go about doing that. So given all of that, let's think about what we're actually going to do in this application and figure out what single component and single property we're going to grab. The thought is maybe if we grab, I've got two NVIDIA GPUs, if we grab NVIDIA GPU temperature, which a lot of people are really excited about anyway, it's probably easier, assuming NVIDIA has a library, so it might make it a little bit easier for us to go through the process with whatever DLL or something that NVIDIA has. So we can focus on this. We'll be doing some communication over PCIe probably, but that will give us a little bit of experience in how to do this. So given that, the basic steps for our application are basically we're going to have to define and locate the data acquisition device, in our case on this GPU. We're going to have to determine the addresses of whatever performance data we want, like GPU temperature. And again, that may be easier using NVIDIA library if there is one. Also determine communication path. Presumably with a NVIDIA GPU, it's going to be over the PCIe. We'll find out. Find access software for our component. In our case, hopefully there's NVIDIA code. And then once we've got all that, on startup, what we're going to have to do is, first of all, detect whatever our performer is, or in our case, our GPU. We're going to have to figure out what model is, what the manufacturer is, and that kind of thing. We're going to have to detect its data acquisition device or devices. And then once we've got that, we're going to have to communicate, access the data, and then grab the data, process it, and plot it. So that's kind of a broad overview of what steps we can make in developing our application. And again, we've already shown how to develop this C# Windows Forms application that's basically grabbing and plotting one value. We can take this application and just add to it our communication with the GPU and grabbing the data and hopefully using some NVIDIA code to help us access the GPU, and then we can just plot the data here. So in upcoming videos, that's what we'll do. We'll take this application, see if we can figure out how to access the GPU data from NVIDIA, and hopefully develop this application, and then we can move on to other performers and data acquisition devices and see how something like this is structured. So that's it for this one. If you're liking these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.